Imagine floating endlessly through space. You are untethered by the pull of gravity. There is no up, there is no down, just you and the vast cosmos all around. This sounds like an astronaut's dream, perhaps, or maybe a bit unsettling. You would drift without any force to stop you, or to hold you to any particular place. It's a strange thought, isn't it? This freedom from pull changes everything. Now, let's take this idea further. Picture a whole planet existing without gravity, a world where nothing holds you down. Can such a place even exist? What would it be like? The very notion challenges our most basic understanding of how worlds work. We are so used to gravity. It is the invisible force that shapes our lives. It keeps our feet on the ground, it holds our oceans in their basins. It even keeps our Earth together. Consider the immediate consequences for such a world. If there's no gravity, what holds the planet together? Rocks, dust, and gas would simply drift apart. There would be no central force to bind them into a sphere, or any shape at all for that matter. It would be a diffuse cloud. To understand a planet without gravity, we first need to ask, what is a planet? Astronomers have a definition. It helps them classify objects in space. A planet must orbit a star. It must be massive enough for its own gravity to shape it into a nearly round sphere. It also needs to have cleared its orbital neighborhood of other debris. These are the cosmic rules of planethood. Now think about our gravity-less object. Could it be round? Gravity is what pulls material inwards. It crushes a large object into a spherical shape. Without that constant inward pull, there's no natural force to make it round. It might be a jagged collection of matter, or perhaps a loose assortment of particles. It certainly wouldn't look like Earth or Mars. It would be a formless wanderer in the dark. What about clearing its orbit? Planets do this with their gravitational influence. They act like cosmic vacuum cleaners. They suck up smaller objects, or they fling them away. This requires gravity, a significant amount of it. Our hypothetical planet has none, so it cannot clear its path. An atmosphere is a precious thing. For Earth, it's a life-sustaining blanket. It provides the air we breathe. It shields us from harmful solar radiation. It helps regulate temperatures, preventing extreme heat and cold. Think of it as our planet's personal spacesuit. It makes life comfortable and possible. Without it, Earth would be a very different, hostile place. Very few things could survive its harshness. What holds this crucial atmospheric blanket in place? You guessed it, gravity. The Earth's mass creates a gravitational field. This field is strong enough to hold on to gas molecules. It keeps them from escaping into the cold, empty void of space. Lighter gases like hydrogen and helium can still escape slowly, but heavier gases like oxygen and nitrogen stay put. This is why we have breathable air. Now imagine our planet without gravity. What happens to any gas? It would simply float away, every single molecule, instantly. There would be nothing to hold it down, no invisible tether. The planet would be in a perfect vacuum, just like the vacuum between planets. This means no air pressure, no blue skies, no wind, no weather as we know it. Water is the elixir of life, at least as we know it here on Earth. When scientists search for habitable exoplanets, liquid water is a top priority. It's a key ingredient. On Earth, gravity plays a vital role in water's behavior. It pulls water downwards. This allows it to collect in vast oceans. It forms lakes and rivers. It even allows rain to fall from the clouds, nurturing the land below. But on our hypothetical planet without gravity, things are very different. Liquid water couldn't pool. It couldn't form oceans or lakes. If you poured out a glass of water, it wouldn't fall. Instead, it would form a floating sphere, or a collection of many tiny spheres. These globules would just drift around. They would bump into each other. They might merge or break apart. A very strange water ballet. Furthermore, remember there's no atmosphere. In a vacuum, liquid water is unstable. If it's warm enough, it would boil away rapidly. The molecules would escape into space. If it's cold enough, it would freeze solid. Then, the ice might slowly sublimate. That means it turns directly from a solid to a gas. So, maintaining liquid water on the surface would be impossible. Movement on Earth is governed by gravity. We walk, we run, we jump. Gravity always pulls us back down. If you throw a ball, it follows a curved path. It eventually falls to the ground. This is our everyday experience. We are so used to it, we rarely even think about it. But it dictates every motion we make. It keeps us anchored. It defines our physical interactions. On a planet without gravity, Newton's first law of motion would be king. An object at rest will stay at rest. An object in motion will stay in motion in a straight line at a constant speed unless acted upon by another force. Imagine trying to take a step. You push off the ground, but there's no gravity to pull you back. You would launch yourself into a slow, endless drift until you hit something. Everyday actions would become extraordinary challenges. Want to sit down? You'd have to tether yourself. Want to throw something to a friend? You'd have to aim perfectly. There's no arc, just a straight line. If you missed, that object would float away forever. What kind of life could exist in such a strange place? Earth's ecosystems are built around gravity. Plants have roots that grow downwards. They anchor into the soil, absorbing water and nutrients. Trees grow tall, defying gravity to reach for sunlight. This structure is fundamental. It dictates how energy flows. It determines where organisms live and how they interact. It is the foundation of our biosphere. Now, on a gravity-less planet, soil wouldn't stay put. It would be a cloud of dust and particles. How would plants anchor themselves? Where would their roots go? Perhaps life would evolve differently. Maybe plants would be like floating balloons, filled with lighter than surrounding gases if any existed. Or they might be like tumbleweeds drifting endlessly. They would need to capture sunlight from all directions, not just from above. Animals too would face incredible challenges. They wouldn't need strong bones to support their weight against gravity, so they might be very fragile. Or perhaps they would be gelatinous blobs. Propulsion would be key. Maybe they would expel gas like tiny rockets, or use fins to swim through the thin, non-existent air, or perhaps through clouds of dust. Hunting and finding food would be a three-dimensional chase. Planets are not born fully formed. They are built over millions and billions of years, and the master builder in this cosmic construction project is gravity. It all starts in vast clouds of gas and dust. These clouds are called nebulae. They are the nurseries of stars and planets. Within these clouds, tiny particles begin to stick together ever so slightly. At first, the forces are very weak. Electrostatic forces might play a role. Little bits of dust cling to each other. They form slightly larger clumps. As these clumps grow, their mass increases. And as their mass increases, so does their gravity. This is where gravity really takes over. The bigger an object gets, the stronger its gravitational pull. It's a runaway process, a cosmic snowball effect. These growing clumps are called planetesimals. They are like baby planets. Their gravity pulls in more dust, more gas, more nearby planetesimals. They collide and merge. This process is called accretion. It's how rocky planets like Earth are formed, and how gas giants like Jupiter gather their immense atmospheres. Gravity is the sculptor. Gravity does more than just build planets, it also keeps them in their place. It provides cosmic stability. Think about our solar system. The sun's immense gravity holds all the planets in their orbits. Earth revolves around the sun in a predictable path. This gives us our seasons. It gives us a stable environment over long timescales. This stability is crucial for life to evolve. Our moon orbits the Earth again, thanks to gravity. The moon's gravity in turn causes tides on Earth. These complex gravitational interactions create a dynamic but largely stable system. A planet without its own gravity would be a rogue element. It couldn't hold onto a moon. Any nearby object would simply drift away. Or if the planet itself was very small, it might be captured by a larger body, but it wouldn't contribute to the system's dance. Imagine a solar system trying to form without this organizing force. It would be pure chaos. Objects would fly off in all directions. There would be no orderly orbits, no predictable celestial clockwork. The very concept of a solar system relies on gravity. It is the invisible hand that conducts the cosmic orchestra. So let's return to our initial question. Could a planet exist without gravity? After our journey, the answer seems clear. No, it cannot. Gravity is not just an optional feature, it is an essential ingredient. It is woven into the very definition and fabric of what a planet is, from its formation to its shape, from its atmosphere to its ability to support water. Gravity is the star of the show. A planet is born from gravity's pull. It is sculpted into a sphere by gravity's embrace. It holds its atmosphere and oceans with gravity's strength. It dances in orbit due to gravity's intricate laws. To imagine a planet without gravity is to imagine a fish without water, or a bird without air. It's a concept that fundamentally misunderstands what a planet is. It's a fun idea, but not a scientific reality. But that doesn't mean the thought experiment isn't valuable. Exploring the impossible helps us understand the possible. By imagining a world without gravity, we gain a deeper appreciation for this fundamental force. We see how it shapes everything around us.